In this video for section 14.1, we're going to look at the relationship between two quantitative variables. Remember that quantitative variables are numbers with units. In section 13.2, we use the chi-square test for independence to look at the relationship between two qualitative variables. So we can represent the relationship between two quantitative variables with a scatter plot. Here's some examples of scatter plots. When we make a scatter plot, we put the dependent variable on the y-axis. This is the one that we want to explain. We put the independent variable on the x-axis, which is the one that's doing the explaining, which explains the variation that we see in the dependent variable. You can kind of think of it as a possible cause and effect. So the independent variable would be the cause and the dependent variable would be the effect. Now, it doesn't necessarily mean that it's a cause and effect relationship, but it possibly could be. So looking at these scatter plots, we see that we have a positive linear scatter plot. So notice that the points sort of follow a line. They're not exactly on a straight line, but you can mostly see the shape of a line there, and that line has a positive slope. A negative linear relationship means that it's a line that has a negative slope. Remember when we're looking at slope from algebra class that we're looking at how the line goes if you're going from left to right. So positive means the line is going up and negative means that the line is going down. We could also have the points follow a shape that's not a straight line but some other shape. So it could be this sort of curve or maybe a curve like this. It could be more of a parabola shape. But any shape that it's following that is not a straight line. Or the points could have no relationship, so they could just be scattered. Both of these show that the points are scattered. A horizontal line would also be considered no relationship. So we have the scatter plot, which we can look at to give us a sense of the relationship between the two variables. But we can also calculate something called the correlation coefficient, which gives us a numerical value that gives us information about the strength and direction of the relationship. Correlation coefficient, which is also called R, is always a number between 1 and -1. If the points fall perfectly on a straight line with a positive slope, then R would be 1. If the points fall perfectly on a straight line with a negative slope, R would be -1. And an R value of 0 means that there is no relationship, no linear relationship between the two variables. So they would be scattered. Or it could possibly mean that they make a shape that is not a straight line. The closer that R is to 1, the more closely the points will fit a straight line. So R values of like 0.9, 0.8, those all mean that the points are pretty close to fitting a straight line. If R is closer to 0, then that means that the points are more scattered. So an R value of about 0.1 or 0.2, that's going to mean that the points are pretty scattered and not following a line very well at all. So here are some examples of pictures that show these R values. We see the R of +1, this is an exact straight line that has a positive slope, and -1 is an exact straight line that has a negative slope. Positive R values always indicate positive slope. So this R is 0.7. You can kind of see a positive line there, but it's obviously not as clear as this exactly 1. Negative 0.55, you can kind of see a negative line there through the points. Then we have an R equals 0 and another R equals 0 where the points are not following a straight line at all. So we can also test whether there is a correlation between two variables by testing the correlation coefficient. And what we're going to get is a p-value in order to do the test, and as usual, we will decide if we're going to reject or fail to reject the null hypothesis by comparing the p-value to alpha. Our hypotheses for testing the correlation are going to look like this. This sort of fancy-looking p is actually the Greek letter rho. So as we know, we have Greek letters that correspond with the letters that we're using. So R goes with the Greek letter rho. Our null hypothesis here is that rho equals 0, which means there's no correlation between the points. And our alternative hypothesis is that rho is not equal to 0, which means that there is a correlation. So we will get the p-value in Minitab and then compare it to the alpha. And as usual, reject the null hypothesis if the p-value is less than the alpha or significance level given to us in the problem. So keep in mind, correlation does not necessarily mean causation. So for example, if we looked at the number of shark attacks and ice cream sales in each month, we would find a positive correlation. But the possibility of a shark attack does not cause people to buy ice cream, and buying ice cream does not make people more susceptible to shark attacks. But they both increase due to warmer weather. So as shark attacks increase, buying ice cream increases. So there would be a nice line with a positive slope, but they're not causing each other. They both have a different underlying cause. So just something to keep in mind. We can only show causation by doing an experiment where we control other variables. So we're going to look at a business application problem here. This is on page 528. It says the Midwest Distribution Company supplies soft drinks and snack foods to convenience stores in Michigan, Illinois, and Iowa. The company wants to know whether there is a relationship between sales and number of years with the company for the employees on their marketing team. Determine the correlation coefficient and test it for significance using alpha equals 0.05. So I have the data here. This Minitab worksheet is also in Blackboard. And we have the sales and the number of years that each employee was with the company. And so we might wonder if people who were with the company longer, maybe they have more sales because they have better relationships with the customers, or maybe they have fewer sales because maybe they're just more lazy, and newer employees tend to be more of go-getters and trying to get more sales. So that would be our question, is there a relationship there? So one way that we can look for the relationship is to look at the scatter plot. So if we go to Graph and click on Scatter Plot, we're just going to do a simple scatter plot. And then we're choosing which variable we want on the y-axis and which one we want on the x-axis. So we're thinking that number of years possibly could cause a difference in the sales. So I'm going to put the years on the x-axis and the sales on the y-axis. And then click OK. And here is my scatter plot. So it does look like there might be a slight relationship here. I can kind of see a line with a positive slope. It looks like as numbers of years increases, sales will increase. But obviously I want to do a little bit more, so I want to calculate the correlation for this. So to do that, I'm going to go to Stat, Basic Statistics, and then down to Correlation. Now this time, for this box where it says variables, it doesn't matter which one is x and which one is y. The correlation actually will come out to be the same either way. So I'm just putting both variables that I want to use in the box. And now if I want the p-value to be displayed, what I need to do is click on Results, and then click on Pairwise Correlation Table to select that third box. Check that box, and then click OK. Click OK again. And then it's going to pull up the graph, kind of similar to our scatter plot that we just saw. But if we scroll down here, we can see the correlation. It's also displayed on the scatter plot right here, the R value. We see our correlation value is 0.833. Remember, if I need more decimal places, I just click on that. Click on the drop-down arrow, and then I can add more decimal places if I need to. So my correlation is 0.833, which is pretty high. It's not too far away from 1, closer to 1 than 0, so that's good. So I'm going to write that down. Oftentimes you will need to put that into the homework problems in my lab. So 0.833. And my p-value is found in this pairwise table. The R value is also in this table too, so it's there as well. And then it shows a 95% confidence interval for rho. So saying that the correlation, we can be 95% confident that our correlation is between these two values. Our p-value is 0.001. So When we compare that to our alpha of 0.05, P is less. So we can reject the null hypothesis. And then remember what our null hypothesis was. Null hypothesis was that there was no correlation. So this means that we have evidence to support the fact that there is correlation. So that there is correlation between sales and number of years with the company.